Our final startup talk of the day is from Nejc, who is founder and CEO of Anemo Robotics. And he will introduce us to some of the challenges of underwater monitoring and also show us some hardware and software solutions. So let's do a round of applause.
Thanks for having us. Thanks for inviting. I have a short presentation about what we're doing at Anemo Robotics and how we're making biodiversity measurable, at least a bit more, with AI-powered underwater cameras for tracking fish. So to start, why we actually decided to do that, I don't want to be too pessimistic here, but we're in a bit of biodiversity crisis, but I think you all know here, so I'll quickly go through this to the second, more positive slide. And we've seen that a lot of companies are trying to solve this problem, that they're pouring a lot of investments in being biodiversity net positive. Not just companies, Danish government has just set aside 500 million Danish crowns in order to support nature restoration at sea. But there's still one problem, and that is that we can't save what we can see. So I think a lot of current methods are very labor intensive. Some of them we also tried on our own. Our very first project was together with DTU Aqua. It was in Vigo, Spain, where we were monitoring a port with some artificial reefs in it. And we're using 25 GoPros. So our day looked like we got up at 6 in the morning. At 7, we would start diving and we would deploy 25 GoPros, only to find them all dead after 10 hours because the battery would run out. So we would have to go back into the water, retrieve GoPros, charge batteries, empty SD cards. And we did that for a month straight. So after we got back, we said, let's not do this again. And we started building on our own solution. I hope this sort of painted the picture of how traditional methods work, that there can be very labor intensive. And what we're trying to do is come up with more of a system that's more scalable, modern, and also less invasive to the nature. So this is how it looks. This is the camera. It has a wide angle front facing camera, has a robust underwater housing. This one on the picture is rated for up to 100 meters of depth. We've got light on top for night monitoring and a very sophisticated anti-biofouling solution, commonly known as a wiper. It's a bit of a funny story. We're looking at all these different fancy solutions like UV lights, lasers, copper meshings, and at the end of the day, plain old wiper work the best. But yeah, we have two different types of cameras. The one on the picture is battery powered. We also have a live camera. Looks just like this one. It's slightly smaller, but it has a cable running to it. So that one can stay submerged almost indefinitely with some maintenance. And this one with the battery can stay submerged for up to 3 months on a single battery charge. Basically, those cameras allow us to capture a lot of data. And we soon realized, the team here, that it takes a lot of time to go through these videos. So we started working on the AI part. And now our projects usually go through these 5 steps where we specify the project, collect the data, train our AI models so that in the 4th step, we can use them, apply them on the full data set. And in the 5th step, try to pull out some insights and see what's actually happening under the water. One of the projects that I wanted to highlight today is called MOSAR project, stands for Monitoring of Small-Scale Artificial Reefs. And it was a partner project between 3 partners. We developed the cameras. We had DTU Aqua that helped us designing the experiment and disseminating some of the results. And we had Reef Circular, who are also a startup from Copenhagen, who 3D printed the artificial reefs that we were monitoring. So about 12 months ago, we installed 2 small-scale artificial reefs, managed to catch some seals on camera. That was pretty cool. Some cod and whitening as well. That was pretty nice to see. And yeah, we started collecting the data. And after 3 months, we had enough to start building the model. This was also done together with DTU Aqua, and they were actually quite happy with results. We were able to detect 12 distinct species with average accuracy of above 80%. And this is how it looks in practice. This is a visualization of AI on the back end, how it works, how it detects different species. And I think it's pretty cool that it can detect even the ones that are a bit further away, a bit harder to see. And yeah, I love this video. Took a lot of work to get it working, so. Yeah, and then we have some results here. This one, the first one we can see. Can we move this? Yeah. Perfect, thank you. So here we can see the first 4 months of monitoring, and we have 3 different sides. So the red one is control side, the blue one is the first artificial reef, and the green one is the second artificial reef. We had 2 cameras at each of the sites, and you can see that already in the first month we had a bit more activity around artificial reefs. Second month, not so much. There was more activity around control side, and then November and December just sort of exploded. We had 6 times the amount of activity around artificial reefs. Here, I just want to put a small asterisk. It's not really, because everyone in the project was like, yes, biodiversity gain. And it's like, yeah, it's a bit too short of a time span to really claim biodiversity increase. But nonetheless, it's still a very good first sign to see that the species liked the new structure and spend more time. So further down the line, there is potential for actual biodiversity increase. The second chart here is what we call average daily activity pattern, and it shows when certain species are most active. Here, for example, we can see black goby and the rest that are very common day species. They peak at around 12, 11 hours in the day. The blue one is the exact opposite. It's crab. You can see that it's not very active during the day and much more active during the night. And the green one, the cod, is also pretty interesting. It shows a spike early in the morning and late in the evening. So pretty clear circadian pattern, which was, of course, fishermen knew this for centuries, but it's still pretty cool that it shows up in the data. And the last thing that I wanted to share here is what we call behavioral heat maps. I think those are very interesting. We haven't seen it anywhere in literature yet, but I think they can say a lot, and they show where certain species spends the most time. So here we can see that, for example, black goby really likes this top part of the reef where the hole is, so that they can basically chill there. We have crabs here. Crabs really like these valleys in between the reefs where they can hide. And an interesting one is also sand eel here. We've been approached by WWF, and they asked us, hey guys, did you see any sand eels? And yes, we did, but they didn't really interact with the reefs. So you can see that they were higher up in water column. And I think that was a very interesting finding as well. And then we have some other species as well. We saw, for example, starfish have very even distribution across the reefs and the harbor wall. And I think then we started to look into interactions with how do different species interact between each other. And this gives us a deeper understanding of how the habitat is being used. And also in the future, it can allow reef builders to focus their efforts for certain species if they need to optimize design for that. Yeah, so our goal is to set up a lot of these monitoring stations all over the world. Well, first, all over the coast of Denmark, to monitor the changes near real time or real time and see how different parameters are affecting marine biodiversity. So yeah, always end with this slide. Join us on our mission to make biodiversity transparent. Thank you.
Any I actually have a question. So you showed at the very last slide how you want to actually expand to different locations, and what are some challenges with moving to different locations, and how much of, let's say, the data from one location can you use for insight in a different one?
Yeah. we also have this sort of two-step approach when it comes to AI training, but we still think that each time we go to a new location, we need to fine-tune the models. I've seen some people claiming that there will be a model that's able to detect every fish species in the world. I don't think that's going to happen anytime soon. So we focus on fine-tuning models each time we go to a new location, and we actually designed our pipeline where we can do that relatively efficiently, quite fast.
Did you see any degradation in the quality of the image during integration? Like, did the brush get everything, or did it still?
The brush worked surprisingly well. We were really surprised by it, and yeah, it removes more or less everything. Even in Danish waters during summer, it was very effective. The bigger problem was, of course, turbidity. But this we've learned that when you have a long-term deployment, you have some good days when visibility is really good, and you have some bad days where you don't see anything. But if you have a long-term deployment, you can get a nice average overall and still have a good feeling.
Yeah, concerning the spatial distribution of how much you can cover, of course, it's challenging. You can only see like 2-3 meters ahead. So you need a lot of cameras to get the spatial view of if you have made a difference. And so did you have any idea of like how many cameras or how you could get the geographic span?
No, that's a great question. And our name is Anemo Robotics. We started with moving cameras, that would go around and scan everything. But then we realized that maybe stationary cameras have some advantages as well. They're 10 to 15 times cheaper. They tend to break down less. And yeah, then we just went with setting up more of them, and they have much better temporal resolution, right? So we think that it's nice to have combination of some ROVs with good locational resolution and some stationary cameras with good temporal resolution. How we usually say, we usually like to set up 4 cameras on each side that we monitor, so that we have 3 of them for statistical significance and 1 for redundancy, because things still break underwater.
Like individuals, or you saw the behaviors as only?
Yeah, it's only per species. We've been asked that quite often, and we are looking into it. Some species, I think it's possible. We're looking into seahorses because they have their distinct pattern of dots on face. But the general rule is if you can tell them apart by eyes, then the AI could probably do it as well. But for a lot of the species that I showed you, at least I can tell them apart.
Thank you very much. And let's see another